Okay, in this video, we're going to solve exponential equations, and in this case, I am not able to equal the bases, and this is another option for solving equations. We are going to use log on both sides when we cannot equal the bases. So since 15, I can't rewrite as a base 2 number raised to some power that'll equal 15, then I don't have any options but to write log in front of each of these expressions. So I'm going to go ahead and write log. I'm going to write log of 2 to the 3x power equal to log of 15. Okay, so this is the other option that we have. Now, whenever we have an exponent, we can bring it to the front and we can rewrite this as 3x log of base 2 equal to the log of 15. Okay, log of 2 and log of 15 are numbers. Since I want to isolate 3x, that means I want to leave 3x alone. I can divide both sides by log of 2, and you're left with 3x is equal to log of 15 over log of 2. Now with your calculator, you can find these numbers. You can find log of 15 and log of 2. So with your calculator, when you look for log 15, you get 1.1761, and when you look for log 2, you get 0.3010. You divide these two numbers and you get 3.9073. That means that 3x is equal to 3.9073. To isolate x, you divide by 3 both sides, and this is what you get for x. X is equal to 1.3024, and that's your answer. Let's do example 2. Again, I cannot rewrite 200 as a base 5 number. 5 raised to what power is 200? We don't know, so I can't rewrite this easily. So we're going to have to use log. So we're going to use the same procedure we did in the previous example. We're going to write log of 5x minus 2 is equal to log of 200. Take this exponent and move it to the front of the log, and you'll end up with x minus 2 times log of 5 equal to the log of 200. Divide by log of 5 both sides so that you isolate the term with the x, and you'll end up with x minus 2 is equal to log of 200 over log of 5, which is, so when you divide log of 200 over log of 5, this is what you get. So this is your expression. X minus 2 is equal to 3.2919. You want to isolate x, so you add 2 to both sides, and you end up with x is equal to 5.2919, and you're done. Here's your answer. Here's one final example, and I want to solve this exponential equation in two different ways. I'm going to do it the easy way, and I'm going to do it the complicated way. Just in case you run across something like this and you don't realize that you are able to rewrite these bases differently and equal the exponents, okay? If you don't see that, then there's something else you can do with log, but it becomes very complicated. Okay, let's go ahead and let's say I did notice that I can write 16 as a base 2 number, and I can write 8 as a base 2 number, and I'll have equal bases. So let's try that. Let's rewrite 16 as 2 to the 4th power. Now remember that 16 is raised to the 3x power, so we raised this to the 3x power. And then 8 I can rewrite as 2 to the 3rd power, but remember that 8 is raised to the x plus 6 power. Whenever we have a power raised to a power, we multiply the powers. So this side becomes 2 to the 12x, because 4 times 3x is 12x. And this side becomes 2 to the 3x plus 18, because we distribute the 3. 3 times x, 3x, and 3 times 6, 18. Okay? Okay. I'm going to change colors because now I have the same bases. That means I can equal the exponent. So I write 12x is equal to 3x plus 18. I can subtract 3x from each side, and I'll end up with 9x's equal 18. Divide by 9 both sides, x is equal to 2. And there you have your answer. Okay, now let's say you did not notice that you could rewrite them as base 2, and you decide to do log log, which is your other option. So let's see what happens when we do that. It gets very complicated, but it's a good idea that you see it so that you know and you recognize it. So let's rewrite it. 16 to the 3x power is equal to 8 to the x plus 6 power. I'm going to do log of 16 to the 3x power equal to log of 8 raised to the x plus 6 power. When we have a log, we can take these exponents and move them to the front of the log. So let's do that. I end up with 3x times the log of 16 equal to x plus 6. Put these in parentheses because this is a binomial, times the log of 8. Now watch what happens. 3x times log 16 is equal to x plus 6 times log of 8. Since I have a binomial here, I have to distribute log 8 times x and log 8 times 6. And this is what happens. Log 8 times x, let's rewrite this here, 3x times log of 16 is equal to log 8 times x, that's the same thing as x log 8. And notice when we multiply, we do not multiply the argument. We multiply the whole log times x, okay? And then we have a plus, and we distribute log 8 times 6. That gives me 6 times log of 8. Okay, so all I did was distribute. And now I have a term here that has an x, and I have a term here that has an x also. So I want to join these terms together on one side of the equation. So to do that, I would subtract log x log of 8 on each side, subtract x log of 8 on each side. On this side, they're gone. On this side, I'm left with 3x log of 16 minus x log of 8 equals 6 times log of 8. You see how complicated this gets? So it's very convenient to watch out for when you can rewrite with the same base because it's much simpler. Okay? Now on this side, notice that this term and this term have something in common. They both have an x as a factor, right? They both have an x as a factor. So I can factor out an x, and this is how you do it, factoring. You factor out an x, and inside you're going to have 3 log of 16. And if you multiply x times 3 log of 16, you'll get back 3x log 16. You have a minus, and you have log 8. So if you distribute this x again, you'll get back this whole expression. I just factored out the x, and on this side I have 6 times the log of 8. Now since I want to isolate x, that means I want to leave x alone. I want to leave x alone. I want to isolate this term, and this term is being multiplied by this whole thing. I can divide by the whole thing. 3 log of 16 minus log of 8. I can divide by all of that. And if I divide one side, I divide the other one. And there it is. Now I have that x is equal to all of this mess, which I have to work out in my calculator. How do I do that? Well, you first look for log of 8 and then you multiply times 6. Okay? So let's do that. In the numerator, log of 8 is equal to 6 times 0.9031. And in the denominator, I look for log of 16 and I multiply times 3. So 3 times log of 16, which is 1.2041. Okay? And that minus log of 8, which is 9031. So the top part is 6 times 9031, which is 5.4185. And in the bottom, I have 3 times 1.2041, which is 3.6123 minus 0.9031. And that equals 5.4185. This is a 5, not a 6. And let me fix that. This is a 5. 5.4185. And in the denominator, I have 3.6123 minus 9031, which is 2.7092. And finally, x will equal to this division. So you write 5.4185 on your calculator and divide it by 2.7092. And that equals 2.0000, which is what we got right here. This number here is not supposed to be here. This was from the previous example. Let's get it out of there. Okay, so you got x is equal to 2. And there you have it. An example where if you don't notice that you can rewrite the bases, it can get pretty complicated. Okay, so take advantage of that. Watch out, always watch out for trying to rewrite it because it's much simpler. I'll see you in the next video where we're going to solve logarithmic equations.